All right, this is a video on polynomials, linear factors, and zeros. So we're going to be looking at factoring polynomials and finding where they equal zeros in this video. So to start off, we're going to talk about just factoring polynomials. So example 1, write each polynomial in factored form. All right, so first thing that we're going to do is kind of look through our polynomial, and we have to strategize first. Just make some observations. The first observation that I see is all the terms have an x. So our GCF is x, so we can take out a GCF. So we're going to divide x out of all the terms. If I take an x out of all the terms, I'll have x times x squared minus 17x plus 30. Just reduce the number of x's in each term by 1. All right. Next, we can still factor further. We can factor the trinomial. All right. We can just factor normally by looking at the factors of 30 that add up to negative 17. That's negative 15 and negative 2. So that gives us x minus 15, x minus 2. But our x, or our other one, is still all the way out on the outside. All right. So we kind of had two steps here. First, we took out the greatest common factor. Then we factored the resulting expression. 2 steps. So what I want you to do before we move on, or before you move on in the video, go ahead and pause it and just write down any questions you might have, or what might you have found challenging about this example, so that I can look at it when I review your notes. All right, for part B, we have to factor again. Let's use the same process. I'm going to look through both terms. All right. I see that we have a GCF and that GCF is x squared. Each term has an x squared. So let's divide out an x squared. Just reduce the number of x terms in each term by 2. So I'm going to have x squared minus 81. We can still factor further. This x squared minus 81 is a difference of squares. So that factors to x plus 9, x minus 9. So I want you to go ahead and annotate this. You can pause it and write down any questions you might have had, or what you might have found difficult or challenging. You can answer them when you come to class. Then what I want you to do is go ahead and pause the video, and I want you to try factoring each one of these expressions. So go ahead and pause, take your time working through them, and once you're done, you can unpause it and check your solutions. All right, so I'll get started with this one. Look through each of the terms. I see the GCF is x cubed. When I take out an x cubed, I'll have x squared minus 7x plus 10. Factor further, I have negative 5 and negative 2 add up to negative 7. So I have x cubed times x minus 5, x minus 2. All right. Next, here, I can see the GCF is x to the 4th. Let's take that out. And I'll be left with x squared minus 121. That gives us x to the 4th times x plus 11, x minus 11. This is our answer. All right. Now, I need you to go through these and annotate, write any questions you might have had or what you learned from these. What was similar, what was different than the last problem. I need you guys to be thinking about your thinking as you take notes. Think about your thinking. All right. Part 2, finding zeros. what are the zeros of each function? So for zeros, I'm finding out where does the function equal 0. I'm finding out where does f of x equal 0. So what I do is I just take my function and I set it equal to 0. So I'm setting this function equal to 0. To do that, I just take each factor and I set each factor equal to 0. This is just like the previous chapter where you take each binomial and you set each binomial equal to 0. All right. Solve each equation. Here, subtract 5. Here, add 2. Here, subtract 3. Now, what's kind of cool and what you can notice is, see this -5? It's the opposite of the number inside. This 2 is the opposite of this number inside, -2. This -3 is the opposite of that number inside. So yeah, we had 3 zeros for this problem. These are our zeros. Now, so you know what this means? If we were to graph this function, all right, this function crosses the x-axis at -5, 2, and -3. All right. And if we were to put it in a graphing calculator, we would have something like this. All right. But these points, you have to make the connection that these points that you got are where this graph crosses the x-axis. These x values are the x-intercepts, or what we call them, x-intercepts. All right, which means that's where they cross, where this function crosses the x-axis. All right, let's do another one. All right, this one's different. I want to find the zeros. So first thing I gotta do though is factor. So let's use the technique from the last problem and first take out an x. X squared minus 14x plus 13. The factors of 13 that add up to -14 are -13 and -1. So I'm going to have x minus 13, x minus 1. All right, just set each factor equal to 0, x equals 0, x minus 13 equals 0, x minus 1 equals 0. Solve each one. Add 1 to both sides, add 13 to both sides. X is 0, 13, and 1. Notice the degree was 3, and it just so happened that we had 3 zeros. The degree is 3, the max number of zeros is 3. All right, so let's go through this. This A was a little easier because we could just solve. You have to understand that these values are where the function crosses the x-axis. So if I ask you what these zeros mean, it's where the function crosses the x-axis. I expect you to be able to explain that. Then sometimes you have to first factor before you find where the function crosses the x-axis. All right. I want you to pause the video and I want you to try these two problems. So go ahead and pause it and try these two problems. All right, I'll get started. All right. Just first thing, set each factor equal to 0. All right. Here, you could take the square root of both sides. Square root of 0 is 0. Here, you can subtract 5 from both sides. X is -5. x is 22, and x is negative 15. All right. Next, let's look at number 2. First, we have to take out x. So I have x squared plus 8x minus 20. Factors of negative 20 that add up to 8 are 10 and negative 2. So I have x times x plus 10 times x minus 2. Set each factor equal to 0. X equals 0. X plus 10 equals 0. X minus 2 equals 0. Subtract 10. Add 2. And we have our 3 x values here. All right. Go ahead, I need you to go back through and annotate. Annotate where you might have had questions. All right. Yeah, you need to be thinking about your thinking. All right. Example 3. You can title this writing a function from its zeros. All right, so this is like the opposite process from the last problem. Instead of finding the zeros, I give you the zeros. So, what is a cubic function in standard form with zeros, negative 2, 4, and 1? All right, so first thing we're talking about a function. So let's name our function. I'll just call it f of x. You could call it anything you want to. You call it g of x, h of x, whatever the first letter of your name is. I don't know, a of x, t of x, m of x, whatever you want to write, equals. All right. Now, the trick is when you write the factors of your function, you're going to use the opposite value from the number you see. So instead of writing x minus 2, I'm going to write x plus 2. So go ahead and think for a second. Instead of writing x plus 4, that's a positive 4, so I'm going to write the opposite, x minus 4. And then we're going to have an x minus 1. The reason being, if these numbers are 0, I should be able to plug them into the function and get 0. If I plug in negative 2 right here, negative 2 plus 2 is 0. If I plug in 4, 4 minus 4 is 0. If I plug in 1, 1 minus 1 is 0. So you just take the opposite. Now, so we wrote our function. It says standard form. So what we're going to do is multiply the function together. So we can just use a box for that, or you can use the distributive property. Just move from left to right. I'm going to do the x plus 2 and the x minus 4. All right, x times x is x squared, 2x, negative 4x, and negative 8. Your like terms are always diagonal this way. Negative 4x plus 2x is negative 2x. So this polynomial becomes x squared minus 2x minus 8. But then at the end, I multiplied these two polynomials together, but I still have an x minus 1 at the end. I have to carry that down. All right. So we multiplied the first two polynomials together using a box. Next, I have to multiply these two polynomials together, but this time I need a 3 by 2 box because I have 3 by 2. So I have x squared minus 2x minus 8 and x minus 1. Start multiplying. X times x is x cubed minus 2x squared minus 8x. X squared times negative 1 is negative x squared. Negative 2x times negative 1 is 2x. Negative 8 times negative 1 is 8. Your like terms are diagonal from each other. All right, so just combine them, and we'll have an x cubed, the first term. Negative x squared minus 2x squared is negative 3x squared. 2x minus 8x, or 2x plus negative 8x is negative 6x plus. All right, and then we can go ahead and this is our answer. So f of x equals this. This is our function in standard. All right, so what I want you to do now is pause the video and I want you to try this problem. All right, pause the video and try, and then you can check your work with me. All right, step 1, name your function. I'll call it g of x this time. Let's write our factors. That's a negative 5, so I'm going to take the opposite, plus 5. X plus 3 and x minus 2. Next, we'll multiply our first two together. X plus 5 and x plus 3 gives us x squared, 5x, 3x, and 15. Add your like terms diagonally. We got x squared plus 8x plus 15. I got an x minus 2. All right, you got to carry down the x minus 2. All right, now we'll do a 3 by 2 box. So I have x squared plus 8x plus 15 and an x minus 2. X times x squared is x cubed. 8x times x is 8x squared. 15 times x is 15x. Negative 2 times x squared is negative 2x squared. Minus 16x minus 30. All right, your like terms will be diagonal. So that gives us x cubed. Negative 2x squared plus 8x squared is 6x squared. Negative 16x plus 15x is negative x minus 30. All right. Oh, and then I should have made a mistake. I'm going to put g of x right here because that's what we named our function. Sorry. G of x equals this. All right. Now, before we do example 4, we got to do a little bit of background on this definition of multiplicity. All right, actually, even before that, I want you to go back to the you try, and I want you to label maybe what you made a mistake on or what you had questions on. All right, for multiplicity. All right, multiplicity is how many times a factor appears. So I have x plus 6, x plus 5, x plus 5, x plus 5, x minus 3, x minus 3, x plus 1, x plus 1. I see this x plus 5 occurs 3 times. This x minus 3 occurs twice, and this x plus 1 occurs twice. So rather than leave it in expanded form, we want to clean this function up a little bit. And I'll write it as x plus 6 times x plus 5 cubed, because x plus 5 times x plus 5 times x plus 5 means x plus 5 cubed, times x minus 3 squared, because there's 2 of those, and then x minus 1 times x minus 1 means x minus 1 squared. All right. Now, if I wanted to find the zeros, I would say just take the opposite. So I'm going to have negative 6, negative 5, 3, and 1 for my zeros. Yeah, we're going to need this idea for the next example. So now for the multiplicity, let's just make a quick chart. Identify your zeros and their multiplicity. All right, the first zero we have is negative 6. The next zero we have is negative 5. The next 0 we have is 3. Then I have 1. All right. -6 only appears one time. There's like a 1 on the parentheses right here. So our multiplicity is 1. -5 occurs 3 times, so our multiplicity is 3. 3 occurs 2 times, or like we saw it twice up here. So our multiplicity is 2. And then, whoops, I should have made that positive 1 should have stayed positive. So really our 0 would be -1. All right. And then -1 appears 2 times, so our multiplicity is 2. Multiplicity is just how many times the 0 appears. So like up here, we had -5 happen 3 times, 3 happened 2 times, and -1 happened 2 times. So for multiplicity, just make a chart first. All right. So now let's go down to here. All right. Find the zeros and their multiplicity. All right. Well, my zeros are x equals 5, -2, 11, and -4. You could just set each, actually let's do it the long way for now in case you're not there yet. So we just have x minus 5 equals 0, x plus 2 equals 0, x minus 11 equals 0, and x plus 4 equals 0. Add 5, we have x equals 5, subtract 2, x equals -2. Add 11, x equals 11, and x equals -4. All right, now just make a chart. Zeros and their multiplicity. All right, so my first 0 is 5, then -2, 11, and -4. 5 only happens one time. -2 has a multiplicity of 3. 11 has a multiplicity of 5. And -4 has a multiplicity of 7. All right, let's do letter B. All right, we have f of x equals x to the 4th minus 2x cubed minus 8x squared. So the first thing we should probably do is factor. So let's take out an x squared. X squared minus 2x minus 8. Next, we can factor again. The factors of -8 add up to -2, or -4 and +2. So I have x squared times x minus 4 and x plus 2. All right, we can now identify the zeros and their multiplicity. All right, the first 0 is 0. That happens twice. The next 0 is 4. That multiplicity is 1. The last 0 is -2. That multiplicity is also 1. So one time as a factor. All right. I want you to pause the video and try this question. All right, pause it and try this one. And I'm going to go ahead and get started. So, first thing, let's factor out an x. So I have x squared minus 4x plus 4. The factors of 4 that add up to -4 are 2 and 2. So I have x times x, well, actually -2 and -2, sorry, that's a -4. X minus 2, x minus 2. But I can rewrite that as x minus 2 squared. Because x minus 2 times x minus 2 means x minus 2 squared. Our zeros are 0, that occurs one time. And the other 0 is 2, and that occurs 2 times. All right. The last part is some background on relative maxima and minima. So, a relative maximum occurs at the top of a hill where a function changes from increasing to decreasing. So like the top of a hill is what we call a relative maximum. So this point right here would be our relative maximum, where the function changes from increasing to decreasing, going up to going down, increasing to decreasing. It's a maximum. Now, a relative minimum occurs at the bottom of a valley, where a function changes from decreasing to increasing, so going down to up. So this point right here we would call a relative minimum. All right, it's at the bottom of a valley. You got to be able to look at a graph and identify the relative maximum and the relative minimum. Or if there's more than one, relative maxima, relative minima. So, what are the relative maximum and minimum of g of x equals 3x cubed plus x squared minus 5x? All right, we're going to use the TI Inspire for this problem. All right, so for the TI Inspire, we're going to graph it to see where if we can find the hills and valleys from the relative maximum and minimum from the graph. So new document. After new document, you're going to go to add graph. We're going to type in 3x cubed plus x squared minus 5x. All right, and we have our function graphed. Now, I want to know exactly where the relative maximum and minimum are. So I go to menu, and I go down to option 6, and then I just go to, let's start with the minimum. All right. So I just click my center button. Now I have my highlighter. What I have to do is press the center button, drag over and highlight that relative minimum and press down again. All right, so now it says that our relative minimum happens at 0.642, comma, -2. The y value is technically your relative minimum. So we're going to take the y here. So y equals -2. All right. Now we're going to do the same process with the relative maximum. Menu, option 6. But then this time choose option 3 because we're looking at the maximum. Press the center button and then drag over and highlight till your relative maximum is highlighted. All right, and it says our relative maximum is, I'm just going to abbreviate that relative max. It happens at 0.865, comma 3.13. All right, I need you to go through and review all of these notes. Keep track of what you might have questions on. I need you to be thinking about how you're thinking. So thinking about your thinking. And I will see you on Monday.